Homogeneous linear systems are special types of linear systems where the right-hand side is all zeros. So therefore all homogeneous systems have a solution where all the variables are zero. And therefore homogeneous linear systems are all consistent. So this is called a trivial solution. And due to this trivial solution, there's only two types of solutions for homogeneous linear systems. So one type of solution is only the trivial solution, or infinitely many solutions in addition to the trivial solution. So this can be seen for the special case where you have a homogeneous linear system of two variables. So for example, if we had x plus 2y, and this is homogeneous, so it must be 0 on the right. So if we write the equation of this line in the explicit form, then we can say that the y-intercept is 0 for all of these two variable homogeneous linear systems. So there'll always be one trivial solution as these lines intersect at the origin, and infinitely many solutions if the lines overlap. Now generally, if the system has more unknowns than equations, then the homogeneous linear system definitely has non-trivial solutions. So for example, in reducing this homogeneous linear system to reduced row echelon form, we have the following reduced form. So x1 is 0, then we have x2 minus 4x4 is 0, and finally x3 plus 2x4 is 0. So if we write the leading variables in terms of the free variable x4, and in a parametric form we have x4 is equal to the parameter t, and therefore we can express this solution parametrically. So as we can see, we have the trivial solution where t is equal to 0, and note that x1 is also 0, or infinitely many solutions for other values of the parameter t. So as you can imagine, elementary row operations don't affect the column of zeros. So effectively, in reduced row echelon form, we have all zeros on the right hand side. So the reduced row echelon form is also homogeneous, just like the original system. And if we had a row of zeros here at the bottom, this would impose no restrictions on the unknowns. So noting the trivial solution, if this row were all zeros, then what we'd have is 0x1 plus 0x2 plus 0x3 plus 0x4 is 0. So this would impose no restrictions, because we have 0 on the left and 0 on the right, no matter what the values of the unknown variables. So effectively the reduced row echelon form either has the same number of equations as our original system, or fewer. So for example, if this row turned out to be all zeros.